Welcome to AMI Day 10. We're going to do the graph of the secant and the cosecant functions today. This first video we'll look at the graph of the secant function. Recall the secant is 1 over cosine x. Let's look at what this is going to do on a calculator. To graph it, we'll go to y equals 1 over cosine x. There is no secant button on the calculator, so we have to graph it as 1 over cosine x. This is going to look like different than any graph you've seen before. We'll talk about why this is what it is. First, recall that the cosine is the x-coordinate on the unit circle. So the largest the cosine can ever be, the biggest x-coordinate on the circle is 1, and the smallest x-coordinate on the circle is -1. Every value of the cosine is trapped between -1 and 1. At pi over 2 and at 3 pi over 2, the cosine is 0. So let's look and see what that does for us. We'll go from 0 to 2 pi again. This time we're going to go ahead and we'll go all the way with all through the angles on the unit circle to pi. 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. Let's look at those values. The secant of 0 is 1 over the cosine of x. Cosine of x is 1 at 0, so 1 over 1 is just 1. Pi over 6, secant is going to be 1 over the cosine. 1 over the square root of 3 over 2 is just a reciprocal, so we're going to flip that and get 2 over the square root of 3. Just go ahead and rationalize the denominator. We get 2 square roots of 3 over 3 for the secant of pi over 6. At pi over 4, secant's 1 over the cosine, so 2 over the square root of 2. We rationalize that denominator, and we get 2 square roots of 2 over 2. The 2's cancel and just leave me square root of 2. Pi over 3, we're going to do 1 over the cosine and flip that cosine. 1/2 becomes 2. Pi over 2, 1 over 0, we can't have that, so the secant is undefined at pi over 2. At 2 pi over 3, cosine is -1/2, so we flip that and get -2. At 3 pi over 4, the cosine is -2 square root 2 over 2, so we flip that and get -2 over square root of 2, and that, just like it did up here, will become square root of 2, but negative this time. 5 pi over 6 is 2 over the square, the secant is -2 over the square root of 3, and if we rationalize the denominator there, we'll get like this, except it'll be negative, so it'll be -2 square roots of 3 over 3. And at pi, 1 over -1 this time. 1 over -1 is just -1. So let's look at this. Let's go from 0 to pi. Let's make this pi over 2. Make this pi. At 0, we'll make 1 right here. -1 here. So the point 1, 0 is on the graph. Pi over 2 is going to be undefined, so we're going to have an asymptote there. If you recall from your graph, the graph had different portions that weren't connected because of asymptotes. We can go to pi over 3. Well, let's go pi over 2 first, pi over 4 first. And that's square root of 2. That's about 1.4. And let's go to pi over 3. That's a little bigger than pi over 4. And that's going to be 2. And pi over 6, 2 square root of 3 over 3, square root of 3 over 3. That's going to be about 1.2 or so. And so we see that this part of the graph goes up and approaches that asymptote. Let's look over at pi. pi, the secant of pi is -1. 3 pi over 4 in the middle there is going to be negative square root of 2 over 2. That's about negative 1.4. 2 pi over 3 is going to be a little smaller than 3 pi over 4. And that's negative 2. And 5 pi over 6 a little bit bigger than 3 pi over 4. Negative 2 squared is 3. Again, that's about 1.2. And we see the curve doing this. Now, you can see the behavior between the minimum here and as the graph goes to infinity, and between the maximum here and as the graph goes to negative infinity. And this pattern is going to repeat. We'll extend this. We'll only look at the 3 pi over 4, 4 pi over 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. At 5 pi over 4, at 5 pi over 4, the cosine is negative square root of 2 over 2. So this is going to be negative 2 over the square root of 2, and that will again go to square root of 2 like it did before. So negative square root of 2. 3 pi over 2. 1 over 0, that's going to be undefined. 7 pi over 4. 2 square root of 2 over, square root of 2 over 2. This is going to become 2 over the square root of 2 when we flip it because we're doing secant. And again, that's going to be the square root of 2 just like it was up here. And then at 2 pi, we're going to have 1 over 1 for the secant, or just 1 again. So let's go ahead and sketch that graph. We'll just go to 3 pi over 2 because we're going to run in the room here. 3 pi over 2 is an asymptote again, like we said. Undefined. 5 pi over 4 is before that, negative square root of 2. So 5 pi over 4 halfway. Negative square root of 2 is 1.4. And you'll see this graph will do this. If we went ahead and graphed over here, we would see now we would go to the top and curve up like this. If we continued back this way and we went to negative pi over 2, we would have another asymptote. And this graph would curve back up toward the asymptote like that. And this graph completes. It's coming down, it goes back up, then goes up, and comes back down, and then it starts to repeat the cycle again. So this time, the period of the function is from negative pi over 2 to pi over 2 is 1 pi, and from pi over 2 to 3 pi over 2 is another pi. So period of the secant function, is 2 pi. No amplitude again because it doesn't have a highest point above the midline. Now we'll look at the domain. And here again, everywhere there's an asymptote, we take out the domain, and these are again negative 1 pi over 2, 1 pi over 2, 3 pi over 2, the next will be 5 pi over 2, 7 pi over 2. We're taking out the odd multiples of pi over 2. Remember, we did odd multiples as 2n plus 1. 2n's an even number, plus 1 makes an odd number, times pi over 2. That takes out all the odd multiples of pi over 2. And the range, this one will be a little different this time, because we see that in this graph, range goes from negative infinity to negative 1. And then there's nothing between negative 1 and 1. It starts again at 1 and goes to infinity. So the range is from negative infinity to negative 1, and from 1 to infinity joined together as a union. And that's the graph of the secant function.